Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics, and these two particular questions belong to paper 9709/43 for the session October November 24. Let's go through question number 3. Question number 3 says a car of mass 1600 kg travels up a slope inclined at an angle of sine inverse of 0.08 to the horizontal. There is a constant resistance of magnitude 240 Newton acting on the car. It is given that the car travels at a constant speed of 32 meter per second. Find the power of engine of the car. So it's all about acceleration velocity, and for this we apply the concept of the motion law of Newton. Before starting our solution, let us draw a diagram of the scenario. So let us draw the diagram. Suppose this is the horizontal ground and the car was moving like this. Well, and this is normal reaction. After that, weight is acting downward. Yes. Then the angle is theta. Angle is theta. Well, and the car is traveling up the hill or whatever. So we are going to apply the concept of the motion law of Newton. Let's show the direction. Direction is this, leaning wise. Okay, the concept is a driving force minus resistance force is equal to mass into acceleration. Well, driving force is, we know the driving force is power over velocity minus resistance to motion. First, a frictional force. There is a constant resistance to the motion is 240 Newton, and there is another resistance to motion is weight is causing also resistance to motion. So weight is mg sine theta, because it is in terms of this triangle, it is a vertical axis, okay, parallel to the ground, equal to mass into acceleration. Look at this, the car is traveling at a constant speed, so there is no acceleration at all, hence right side is 0. Now power is to be obtained, but velocity is given. Velocity is 32 meter per second, so let p be unchanged, and velocity is 32 minus 240. Mass of the car is 1600. Acceleration due to gravity is 10, and sine theta, the value of sine theta is 0.08. So 0.08 equals 0, or p over 32. P over 32, let me zoom it out so that I can write well. Yes, so p over 32, p over 32 is equal to, sorry, it was not 24, it's 240. 240 plus 1600 into 10, 16,000 into zero point 0.8. If we multiply 1600, I mean 16,000 into zero point 0.08, let us see how much is this. 16,000 in 1280, 1280 Hence our P is equal to, finally P is going to be 240 plus 1280. It is going to be 14, 15, 20 into 32. So let us multiply 1520 1520 into, so it is 48 48,640 is the power the car is maintaining. What? So that is what the answer to the first part of the question. The next question says find the acceleration of the car when its speed is 24 meter per second and engine is working at 95% of the power. So power is equal to, let us find power. We are still under the same diagram. So P is equal to 95% of how much? 48640. 48640 equal to, let us find 95% of 95% equal to into 95%, equal to 46208 watt. Okay, this is the power we are going to use now. Well, the question has told us to find the acceleration. Okay, so the same concept is going to be applied for finding acceleration. Still the car is moving upward, sliding up, so the direction is same. So driving force minus resistance force is equal to mass into acceleration. Driving force is equal to P over V, power over velocity, and resistance to motion is also unchanged. First, frictional force was 240, then resistance caused by the weight is mg sine theta equal to mass into acceleration. Mass of the car was 1600 kg into acceleration. Well, power has already been obtained. We have got that power is 46208. 46208, and velocity is given. How much is the velocity? Velocity is 24 meter per second. So 24 minus 240 minus mg sin theta, as the system is still as it was, so its resistance due to weight is also same, which was 1280. So let us substitute 1280 is equal to 1600 into acceleration. 1600 into acceleration. Well, then it is going to be, if we leave it unchanged, 46208 over 24 minus 240 1280, we have already calculated, it was 1520 equal to 1600 a. Okay, now it is going to be, if 16 is transposed to the left side, it is going to be 46208 over 24 into 1600 minus 1520 over 1600 equal to, if we dissolve 10, it is 152 over 160 is equal to acceleration. Now let us calculate our acceleration using the calculator. Hence our acceleration is going to be, so it is 46208 over, let us use the calculator, 46 is going to be 0.253 meter per second square is our acceleration due to gravity. So that's all about the solution to both of the parts of this question. Let's move on to the immediate next question. Well, the next question is over here. The next question says, two particles A and B of masses 3 kg and 6 kg respectively lie on a smooth horizontal plane. Initially B is at rest, A is moving towards B with speed 8 meter per second. After A and B collide, A moves with speed 2 meter per second. Find the greater of the two possible total losses of kinetic energy due to the collision. Okay, we know for finding the loss due to loss of kinetic energy due to collision, we applied the concept of the conservation of momentum, and the components of conservation of momentum are velocity before the collision and velocity after the collision. So let us find one after the other. So we are going to apply the concept of the conservation of momentum, that is ma and initial velocity, I mean velocity before collision of A plus mass of particle B and velocity before the collision, velocity of B before the collision equal to mass of particle A and velocity after the collision plus mass of particle B and velocity after the collision, velocity of B after the collision. So let us substitute the value. Mass of the particle A is 3 kg and B is 6 kg. So 3, and A was projected. A moves with the speed of 2 meter per no. A is moving towards B with the speed. So before collision, A was moving at a speed of 8 meter per second. Plus mass of particle B is 6 kg and it was at rest. 6 and B was at rest. Look at this. Lie on a smooth horizontal plane. Initially B is at rest. B is at rest. After the collision, mass of the particle is 3, and after the collision, A was moving with the speed of 2 meter per second. Let's assume that both the particle A and B were moving to the same direction. That's why the symbol is also same. Then MB is 6, and we are going to find the velocity after collision, velocity of B after collision, velocity of B. Now you may raise a question that how can the initial velocity, that this 8 meter per second, be the velocity just before the collision. Look, it is written that the plane is smooth. As plane is smooth, so the velocity, initial velocity when the particle A was projected till it collides, the speed, velocity, acceleration must remain same because there is no contact force. I mean, there is no resistance to motion, or there is any frictional force. There is no frictional force acting on it. In short, the particles are lying on a smooth plane, so the velocity, initial velocity as well as the velocity just before collision are same. So it is going to be 24 minus 6. Minus 6 is equal to 6 velocity of particle V after collision. So if we divide 18, hence it may be the last of all step. Hence velocity of B after collision is going to be 24 minus 6 means 18. 18 over 6 means 3. 3 meter per second. Assuming that both the particles after collision were moving towards the same direction. Okay, if the direction was different, the second possible case. Second possible case, applying the same concept, that is, let us change the ink. Mass of particle A, same concept, conservation of momentum, UA plus MB UB, velocity before collision plus equal to mass of particle A and velocity just after collision plus, okay, here we may make a change. Look at this, we are assuming that after the collision, look at this, mass of particle A is less than the mass of particle B. It is over here 3 kg as well as 6 kg. So it may happen that after collision B, suppose here it is B, okay, B is over here and A is moving towards B, okay, towards B. It may happen that after collision A may change its direction, okay, A may changing its direction, A may move backward. So if A moves backward, this is for A, okay, after collision. Before collision A was moving towards B, but after collision it may happen that A is moving backward because the mass of particle A is less than that of particle B. So if A moves backward, so direction will be different, velocity is also negative. So minus MA and velocity of particle A after collision plus, but B cannot move to the backward direction, okay, because B was A hit B, that's why B cannot change its direction. If B moves, B must move onward, I mean forward direction. So mass of particle B and velocity of B just after collision. So mass of particle A was 3 and initial velocity was 8 plus mass of particle B was 6 and initial velocity was 0 minus mass of particle A is 3 and after collision it was actually 2 meter per second plus mass of particle B was 6 and final velocity after collision is to be obtained. So it is going to be 24 plus 6, that is 30. 30 is equal to 6 into velocity of particle B. Hence velocity of particle V is going to be 5 meter per second if A moves backward after collision. So this is the second possible case of velocity. Now we are not deviating from the question. Actually the question told find the greater of the two possible total losses of kinetic energy. So they have told us to find the losses of kinetic energy due to collision. So we know the concept of losses of kinetic energy. So first case was V was let us change the V equal to 3 when losses of total energy loss of not losses loss of total energy or energy, you know the formula is negative change in kinetic energy of A minus changing kinetic energy of the particle B, well, equal to, we know that what is the concept for finding the change in kinetic energy, you know, half of m half half of m v square of v square of a particle A minus half of mass into the same concept velocity of B, velocity square of B. Now we are going to apply the values we do have, equal to negative half. Mass of the particle A was 3 kg and velocity. Now in velocity, please don't get confused. Velocity square means final velocity minus initial velocity. Square of final velocity minus initial velocity. So let us see about A. About A, look, before the collision, the velocity of A was what? It was the velocity of A, 8 meter per second. And after collision, the velocity of A was 2. So we are writing final velocity, square of final velocity minus initial velocity. So please don't get confused. So final velocity is 2 square and initial velocity is 8 square. That is 2 square minus 8 square. 2 square minus 8 square. So is the second case, half, and mass of particle B is 6 kg. Initial velocity was 0 and final velocity was, in the first case we have written final VB. Let us write V of B, it was 3. Okay, so it is going to be just 3 square 3 square minus 0 square. Initial velocity was 0 because particle B was at rest initially before collision. Equal to, if we simplify, it is going to be 8 square means 64. 64 minus 4 means 60. If we divide 60 by 2, it is going to be 30. So 33, 90. It is 90 joule minus, here 2, if we divide 6 by 2, it is 3. And 3 is 9. So 3 square 9, 3 is 27. So 27. The first possible losses is 63 joule. 63 joule when P was, when final velocity of particle B was 3. Now they have told to find, look at the question, they have told find the greater of two losses, greater of the two possible total losses. So we have just found one of the losses. Let us find the second case. Okay, then changing the ink, we can write here, okay, V is equal to V of particle B is equal to second case. Second velocity was 5 meter per second. 5 when loss of energy, same concept, we are going to apply the same concept. When loss of energy is equal to change in kinetic energy of particle A minus change in kinetic energy of particle B after collision, before and after collision, kinetic energy of B. Same way, if we apply the formula, it is going to be half m v square. M of particle, I mean mass of particle A was 3, and final velocity after the collision of particle A is 2 square minus initial velocity before the collision. Speed of particle A was 8 meter per second, so 8 square minus, same way, mass of particle B was 6, and final velocity, it was 5 square, 5 square minus 0 square. Initial velocity was initial velocity, I mean velocity before, velocity of particle B before collision was 0, it was at rest. So if we simplify this, 64 minus 460, and sorry, here I forgot to use the negative symbol. Okay, so negative negative positive 60, 180 90, so it is going to positive 90 minus, here 3 and 25, 325 is a 75 joule, so this is 15 joule. Okay, now the question have told us to write the greater loss. Let's see which one is greater. When velocity of particle B was 3, then the total loss was 63 joule. And when the velocity of particle B was 5 meter per second, then the loss of total energy was 15. So greater possible value is 63. Hence, total loss is greater loss. Find the greater of the two possible loss, total loss. Okay, hence greater loss of energy, greater loss is equal to 63 joule, 63 joule, and that is what the answer to the final part of this question, I mean answer to the question number 4. Okay, I think you have understood. Here there were two possible values of velocity of particle B, that's why there are two possible amount of losses, and among them we have picked up the greater loss after the collision of these two particles. So that's all about the solution to question number 4, and I can show you the question solution to question number 3, which is so. So thank you all for being with me, and I tried to explain every tiny part of these two simplest questions. May Allah bless us all with beneficial knowledge. Fi amanillah.